of cutting speed, feed, this one is related. Related quantities, there are important points. So important, very important. So first one is a related quantity in machining is area of uncut before cutting the machine workpiece, metal removal rate, MRR, and machining time and power consumption. So these are the important quantities in machining, related quantities in machining. Suppose area of uncut means we can see it is the cross-sectional area of the layer, the work material being removed. It is very important. It is the cross-sectional area of the layer of the work material being removed. Second, it is expressed in the product of feed rate F and depth of cut T. So the uncut chip, area of uncut chip is given by AC equal to FD, where AC is the uncut chip, area of uncut chip, F is the feed, D is the depth of cut, small f and small d. So area of uncut chip is denominated by A suffix of C. Capital A suffix of C is the area of uncut chip, and F is the feed rate, small f, D is the depth of cut D. So metal removal rate. So in case of metal removal rate, generally it is written as MRR. Capital M, and M is the metal, R is the removal, R is the rate. So briefly written as MRR. So in case of metal removal rate, so it is defined as the volume of the material being removed per unit time from a given workpiece. Clear this point? Metal removal rate as the volume of a material being removed, how much volume of material, how much volume, that is material removed from the workpiece. The volume of the material being removed per unit time from the given workpiece, it is called as MRR, metal removal rate. So metal removal rate is given by MRR is 1000 FdV mm per minute. 1000 FdV mm per minute. So MMR is given by, so in that F is the feed, so it is a mm per stroke, and D is the depth of cut in mm, and capital V is the cutting speed in meter per minute. MRR is the metal removal rate. So the metal removal rate 1000 into FdV mm per minute, where small f is the feed rate, mm per stroke, D is the depth of cut in millimeter, mm, P is the cutting speed in meter per minute. So using this equation, you can easily find out the metal removal rate. Metal removal rate equal to 1000 into FdV. F is the feed rate, D is the depth of cut, D is the cutting speed, and we will get the MRR in meter per minute. So next one is a machining time. It is very important. Machining time, it is very important. So in case of machining time, it is the time required for cutting the tool to remove the excess material from the given workpiece in order to obtain the desired shape, size and finish. It is very important to starting to end. Machining time is how much time is required to prepare the component. It is the time required for the cutting tool to remove the excess material. Whatever raw material is given, then according to drawing you can prepare that work component. So excess material from the given workpiece in order to obtain desired shape, size and finish. These three parameters are important. Desired shape as per drawing, and shape and desired size and desired finish. It is called as how much time required to ready to the component starting to the end point. Okay. So next is machining time is given by length of the tool travel, how much length tool travel, divided by feed into spindle speed. Feed into spindle speed, feed rate into spindle speed. So machining time is given by length of the tool travel divided by feed into spindle speed in minute. Generally mathematically it is written as machining time is generally denoted by capital T. So capital T is equal to capital L. L is the length of the, capital T is the machining time. How much time required to cut the or to finalize the product or component. T is equal to L divided by F by N. Here T is the machining time and L is the length of the tool travel and F is the feed and N is the spindle speed. We will get the machining time in minute. So next power. So the power is a very important. Power is a energy required. Power means the energy required in a unit time to perform any machining operation. To perform in any machining operation, power is the energy required in unit time to perform any machining operation. Power rate is usually product of the specific cutting energy and metal removal rate. It is usually product of their two, specific cutting energy and metal MRR, metal removal rate. So power equal to specific, P is the power, S is the specific. There is a specific cutting energy. Power is equal to P suffix of S. Power specific energy into MRR, metal removal rate in kilowatt, power in kilowatt. The power is generally denoted by P is equal to PS. PS is the specific cutting energy. P, capital P suffix of S, that indicates for the specific cutting energy into MRR. MRR means the metal removal rate. So we will get in power, we will get in kilowatt. The specific cutting energy is the energy required to remove the unit volume of material. Specific cutting energy is the energy required to remove the unit volume of material. Specific cutting energy is the energy required to remove a unit volume of material. So it mainly depends on the properties of the work material and undeformed chip thickness. It is mainly depend on the properties of the work material and undeformed chip thickness. So the P equal to power, P equal to Fc divided by Pc in kilowatt. So where Fc is the cutting force, Pc is the cutting velocity. Pc is the cutting velocity and cutting force. We will get the power in kilowatt. And last power consumption, that is a electric power. Power consumption is different and power is different. Power consumption is a example. Power consumption is electric. How much electricity is required to ready to prepare the component. So it is the total power consumed by the machine tools for carrying out of specific operation on the work material. From starting to end, how much power is required to prepare the component. So in this